who's been following the rapid developments in AI, you will know that graphics processing units or GPUs are absolutely essential. These powerful processors fuel the complex computations needed for training and running artificial intelligence models. Now, whether it's natural language processing, computer vision, predictive analytics, GPUs are the workhorses of AI. Hello and welcome to today's episode of Analytics Inside, where we explore the most pressing issues in the world of technology and innovation. And I'm your host, Priya Dayalani. Now, while we're talking about GPUs, there's a catch here. There's a global GPU shortage, and this is posing a real problem. Businesses around the world are finding it difficult to access the compute power they need to develop their AI capabilities. Today, we are going to talk about what's causing this shortage, how it's impacting businesses, and most importantly, what steps companies can take to overcome this significant challenge. So, let's welcome Dali Kilani, CTO and co founder of Flex AI. Hi, Dali, how are you doing?
Hi, I'm doing well. Hi, Priya. Thank you for having me today.
Thank you so much, Adali. It's a pleasure to have you with us on a podcast today. And of course, we'll be diving deeper into the pressing issue in today's tech world, that is the GPU shortage. But before that, if you can help us understand or brief us about Flex AI, seems a very interesting name. So if you can tell us more about Flex AI, its specialization, or any particular solution the company is offering.
Yes, so Flex AI is a company based in Europe with presence, actually strong presence in India from day one. Our goal is to simplify and bring more compute with less complexity. We realized before the inception of the company that this new phase of AI consumption and AI growth would require the usage of highly complex computer infrastructure and AI infrastructure that in many cases will be very difficult for people to master, and that in order for the whole promise of AI, revolutionizing healthcare, education, and many other day-to-day other services in our day-to-day lives, somebody needed to kind of put together full AI infrastructure that is simpler, that is more available. Especially, we talked and you mentioned GPU shortages. One of our aims is to bring more choice, make it more accessible, allow people to consume this infrastructure on demand, and all in all, just make it more accessible.
Great, quite fascinating, Dali. Thank you for helping us understand about Flex AI. And I also believe that you bring a wealth of experience in hardware design, middleware, cloud infrastructure, and you've worked with some leading global teams. So, can you tell us more about yourself, Dali? How has been your journey till date, and your contribution, your role towards the company?
Yes, absolutely. So I personally grew up in Tunisia, actually in North Africa, and then I followed my studies in Europe, in France, and then my graduate studies in the US, where I graduated from Stanford, actually, from a Master of Science in Electrical Engineering. I started my career in building telecom equipment, and then at a company called Sienna, and then my journey moved to building GPUs at NVIDIA. This was 20 years ago. This is where I met my co-founder, CEO, Brajesh Tripathi, and we kind of built basically a friendship that while we were designing the first GPUs that were meant to do other tasks or to accelerate other workloads other than 3D graphics and gaming. And this is back in 2024. And after that experience at NVIDIA that opened my eyes to what is now called accelerated computing, I moved on into various startups since 2007, building cloud solutions at scale, developing fully integrated hardware and software designs to tackle various challenges from embedded computing, from secure delivery of desktop sessions in the cloud. But also in my last venture before I started Flex AI with Brajesh, I was CTO and late co-founder actually with a company in the healthcare space. And that's where I witnessed the impact of using AI. So a company called Lifen, it's based in France. And the main innovation there was to bring AI as a co-pilot to the healthcare practitioners in helping them in automating administrative tasks so that they had more time for patient care. That I saw firsthand, I experienced firsthand the impact of AI when it's used in verticals and in critical functions, and that led me to realize that as I saw the Gen AI wave, start with ChatGPT 2 years ago, I realized that there's a massive need into reducing the complexity and helping people bring the power of AI into their own vertical applications, and that's what motivated me to start this venture and tackle this complexity and this accessibility challenge that is out there.
Great, quite an impressive journey, Dali, and I'm really glad to hear about your entire journey and the impact you have had so far within the company. And it sounds like your role requires a blend of strategic thinking and more of hands-on leadership in the core tech development at Flex AI. So let's start by framing the issue in its global context. Now, the demand for GPUs has surged exponentially over the last few years, driven not only by the boom in AI but also by other sectors like cryptocurrency mining, gaming, and even high performance computing in scientific research. Now, COVID-19 and the resulting supply chain disruptions only escalated this problem. And as more companies begin to realize this transformative power of artificial intelligence, the competition for GPUs has become fierce that way. So, can you help us understand the current situation of this global GPU shortage and how it is affecting businesses across industries?
Yes, absolutely. So, what the whole industry and the whole ecosystem has been witnessing is that the demand has skyrocketed ever since that first demo of ChatGPT. People have realized that they could apply the latest generative AIs, whether that's to analyze text, people use it for summarizing information, get a summary of your PDF, upload your PDF to a Gen AI powered, for example, chat agent, or we're talking about agentic workflows now, getting machines to do, follow workflows and execute things. The demand has just skyrocketed. At the same time, that's demand for using models, what they call traditionally in the inference side of things. But there's also the demand for training new models, making them learn new things. We started with models that understood only text, but this expanded into models that understand video, understand audio. We're at a point now where you can say, "Hey, can you generate me, a small feature film, basically, based on a script?" So text to video. People have been generating automatically and programmatically, ads and various other content, and creating these models that are richer, not even using them, but creating them. That's what's called foundational models, has required a massive amount of compute, a massive amount of capabilities, GPU clusters in the tens, if not hundreds of thousands. People are talking about, at least the largest companies, the Googles and Metas and OpenAIs of the world, have been talking about using clusters that include up to 300,000 GPUs in 2025 in order to build these foundational models and make them learn on all the content that's available. And then make them available to other businesses, enterprises, even regular users, to use them in their day-to-day workflows. This demand has been forecasted to the amount of compute that's needed to create a foundational model is doubling every 6 months. Just to give an idea, so what was the amount of compute that was used to generate GPT 3.5, which is the version of Gen AI model that was used for the original ChatGPT, that amount of compute versus what is being used for GPT-5, there's a factor of 100, even though it's just 2 years ago and 2.5 years ago. Because of the doubling every it's almost a factor of 100 that's actually has happened ever since that, and that demand keeps going up and up and up. there's a lot of conversations around we're running out of data to train on, or they're running out of data to teach these models. But what people actually kind of don't realize is that once all the public data that is on the internet has been absorbed and has been pushed into being trained on these models, there's still a lot of private data. Every single enterprise that wants to benefit from the usage of Gen AI internally wants to kind of refine what's called fine-tuning of these models. So to teach these models how the internal documentation works in the company, so that when people want to generate a new report, for example, it gets generated automatically, but based on the templates that the company uses. All this private data fine-tuning, there's way more private data than public data in businesses today across the world. So that's another frontier, and there's another large-scale data sets that are available for training, and therefore are going to need even more GPUs. So the demand keeps going. The amount of compute that is required for pushing all these use cases that people are thinking about is massive. And on the flip side, the main supply of compute comes from a significant player that is NVIDIA, that is the most valuable company in the world today, that has been increasing supply consistently, but it just can't keep up with the demand. And this gap between the supply and demand, especially outside of the main markets, outside of the US, more specifically, this gap is even larger in Europe, and it's also large in India. We've been seeing multiple initiatives in India to bring more GPUs and build these clusters. But it's still a challenge because the use cases haven't necessarily always picked up. We all understand that the demand is there, but there are some skill shortages. For example, the complexity is a little too high, and this is where Flex AI can help bridge that gap in the areas where the supply is there. We understand the demand, but it's kind of the pent-up demand, or the theoretical demand is there, but there's a gap in between around the skill set, around the consumption models, around the pricing models, and this is where Flex AI is trying to help.
Great. Thank you for, shedding light on the current state of the global GPU shortage and how it's kind of having a ripple effect across different industries. And it's clear that this shortage isn't just like a supply chain issue, but like a major roadblock for innovation, especially for businesses who are heavily reliant on artificial intelligence and high performance computing. With addition to your response, I think it's also considering, we should also consider the role of AI chip innovation. While GPU is currently the gold standard for AI compute, companies like Google and NVIDIA are developing more specialized chips such as tensor processing units and AI-specific accelerators designed to handle the demands of machine learning models more efficiently than the traditional GPUs. Now, these chips can deliver impressive performance for AI workloads, and as they become more widely available, they might offer a viable alternative to GPUs for businesses facing shortages. So, but beyond the technological solutions, there's a broader question of strategy. I feel that businesses need to think about, like, how can they make smart decisions now to ensure that they're not crippled by GPU shortages in the future? So, I think that this is where like leadership strategy comes into play. So, what are some strategies you think that businesses can employ to overcome the current GPU challenges before we have a very viable alternative to GPUs?
So there are multiple strategies that people can follow. First of all, there are multiple use cases in this Gen AI space. There's the use case, the simplest one that is the least intensive in GPU use is what is called, retrieval augmented generation, which doesn't require too much GPUs and is based on using existing models in order to kind of tap into existing data sets. This is typically when you try to, find an answer to a question where people have these, chatbots and things like that. Choose the right approach to the problem you're trying to solve. So the first approach is to pick among the different use cases. As I said, one is what's called RAG, so retrieval augmented generation. The second one is when you want to have kind of a more precise, an approximative answer is not good enough, and you want a more definitive or more refined answer. That's called fine tuning. So take an existing model, kind of teach it your own ways of doing things, think of a legal firm that's trying to help its own lawyers be more effective, and tries to generate, for example, contracts based on traditional templates. Instead of just taking a template and filling in certain fields, you could get a generative AI model to learn from all the contracts that the firm has ever created, and then you can say, I would like to have a contract between company A and some partner in the US, for example, and for a collaborative project, and I would like to have clauses that protect IP and this and that. And then the generative AI model is able to generate a fully compliant contract because it has learned on the historic contracts that the firm has generated. That's what fine tuning is about. And then in certain cases, one cannot find these off-the-shelf generative AI models, traditionally open source or open weight, which means they're usable under licenses that are permissive enough for creating a business around them or using them in, say, within an enterprise. If you can't find an off-the-shelf model, you have to build your own for specific verticals. Some startups are actually going in this direction. And in that case, if that's absolutely necessary, one needs to be ready to spend the resources to not acquire, but kind of get access to the compute pools and the compute capacity that is needed to generate these models. So the first thing to do, as you asked, is to pick the right answer for the use case. If you're trying to do a self-service type of chatbots for a help desk type of situation, you don't really need to spend to find GPUs and do something complex. Stick with a RAG type of setup. If you're in a domain specific, but you're still based on text and on traditional verbal exchanges, you can do a fine tuning of off the shelf models like the ones that Meta provides and Llama 2, Llama 3. Or if you're in a new area that doesn't have any good open source based models, then you need to actually go after GPUs. So pick the right answer and the right solution for the use case. That's actually rule number one. Rule number two, try to rely on managed services like the ones that Flex AI offers, and not just to kind of mention Flex AI. There are many other options in the market, but because in order to limit or reduce the cost and the complexity and the challenges around accessibility to GPUs, one shouldn't try to kind of go and reserve GPUs for a long amount of time and build the whole setup and clusters and this and that in order to take advantage of this compute capacity, because there's a lot of complexity around setting up clusters, tuning them, configuring them properly, being able to set them up so that you can do the training or even run inference, for example, or at least use these models in an effective way. Rely on existing services that have the expertise, because we've seen people get these GPUs and reserve them, say, for 2 weeks, and then spend 3, 4, 5 days setting everything up before they can even do anything on them. So that's usually a trap and a waste of resources and money. And of course, while those GPUs are being set up, they're not creating value, and they're staying idle, and nobody's getting access to them. So that's a waste. So we usually, when people identify that they absolutely need to have access to GPUs, we recommend to them to use services that have already set up everything, so that those customers can focus on creating the value that they need instead of trying to set up things from the ground up.
Great. That was quite insightful, Dali, and thank you for sharing that. And it's very clear that that the global GPU shortage can be a significant hurdle, and it's very important to deploy certain strategies in terms of tackling this particular challenge. Now, of course, we know that the compute is scarce and has become a key bottleneck in both the training of large-scale AI models and the deployment of these AI products. I mean, Elon Musk told a room full of CEOs in May 2023 that GPUs at this point are considerably harder to get than drugs. So, what do you consider to be an AI compute hurdle, and how it is affecting the progress of AI-driven businesses? Compute hurdle, yeah. What do you think is the exact AI compute hurdle, and how it is kind of affecting the
So,
progress of AI-driven?
yeah, sure. Basically, the journey today for any company that's trying to take advantage of AI at scale, the first thing is identify what is the right setup for the use case. The second thing, once you identify the setup, going and securing supply to these GPUs is already a challenge on its own. Once you secure that supply, you have to set up everything in order to actually use those GPUs. Once you use them, you have to make sure that you're using them efficiently so that the cost is compatible with a positive ROI for that project. And even once you set them up, you need to, if you're going to deploy those AI workloads or let's say, these assistants and agents and this and that, you have to keep up with the updates and the management and all that stuff. So this whole complexity and the whole journey across all these things is what makes it a hurdle. And the second thing is, of course, you mentioned it earlier in the conversation that there are some emerging alternatives, or at least options for AI hardware that are coming along. But even those, they come in and they bring some solutions in certain cases. But then when you have more choice, theoretically, there's another layer of complexity that comes in now. Should I use, a GPU? Should I use these specific kind of AI accelerators that are great at certain things, but not on others? How do I figure out whether these alternatives work for my use case? All this complexity makes it a hurdle because people can't go from A to B basically and create the value that they have imagined from day one easily, either because they can't get access to these compute solutions, or when they get access to them, they can't really use them effectively. And so these are the hurdles that we see in the market today.
Right, and I think that's very important that while I think if you understand the entire scenario, it's not just about scaling your AI capabilities anymore. It's about doing it in a way that's both efficient and sustainable, given the limitations of the hardware market currently. And as more organizations look to balance their growth ambitions with the realities of supply chain constraints and budget pressures, they're also being forced to rethink the strategies around AI compute. And that's when you suggest certain strategies as to how they can tackle this particular challenge. But again, if you want to have like a balanced approach, how can companies efficiently balance the need for massive AI compute power with the reality of limited hardware availability?
Yeah, so there are multiple avenues here. I mean, we know that the current imbalance and the current gaps are not going to last forever. There are more options coming to the table. There are more, I wouldn't call them alternatives, but I'd say more choice, whether it's coming from AMD, coming from Intel, coming from other chips that are part of offerings from, Amazon and Google, etc. So building, I would say one recommendation is if you're building any new AI kind of workflow or models or doing any fine tuning, try to use tooling and rely on frameworks like PyTorch, or use toolings like the one that Hugging Face provides that allows you to kind of stay at an abstraction layer that doesn't tie you necessarily to a specific architecture or a specific target. Most of the new options are coming to the market that's coming and sliding underneath the PyTorch framework, and they're all built in and natively supporting the PyTorch framework, so that when people do support or at least create their own or do fine tuning for their models or create their models, they need to stick with an abstraction layer like PyTorch that will allow them to solidify or make sure that their investments today are going to last for a while. That's one recommendation I would make. The second recommendation is don't try to be too advanced, and make sure to use the right solution for the right target or objective. In building too complex of an AI application from day one, that can become a challenge. I would say from the beginning, it's probably much easier to experiment and do POCs and even small scale rollouts by using managed APIs for, say, model as a service solutions, where you can provide a model and they can handle everything and giving you an API endpoint. Very similar to what OpenAI has provided as an API to consume their models. Rely on those, integrate those into applications, and then try to do cost reduction and kind of internalize those APIs within the company's IT environment, because if starting from the beginning for experimentation, one tries to rely on access to GPUs, that becomes a challenge that makes the projects probably have a lower chance of success. So these are my two recommendations.
Right, and that definitely makes sense. And but as we look ahead, it's really essential to think about how technology will continue to evolve and meet these demands. Now, the pace of AI advancement isn't slowing down, and I think that's pretty much clear. And with that comes the need for even more efficient and scalable solutions. Now, while GPUs have always been the backbone of AI compute for years, we are beginning to see the emergence of alternative technologies that could change the game entirely. So, looking ahead, do you see any emerging technologies that could help businesses overcome these GPU constraints in the long term?
Yeah, so as usual, so as we mentioned earlier, there's the creation. There are two main phases in AI workloads. There are two types. There's the creation of models and the consumption of models. So the creation of models is what's called training, or sometimes also fine tuning. If you're just starting from an initial model, you're just making it learn small things. And there's the inference side. Inference is when you're using a model, you're just talking to it, basically. You're getting responses back. The infra side, we are seeing emerging solutions that are optimized. Some people have came up with chips that they call it the first transformer accelerators, meaning that they rely on they bring hardware that runs the algorithm, which is called transformers, which is at the heart of this Gen AI and Wave and LLMs, large language models. There's a technology that's called, or at least an algorithm that's called transformers, and people have come up with ideas of how to build hardware that makes this algorithm run fast. For example, can this can this hardware do accelerate training? Not so much, but it's actually pretty good for inference. There are also new innovations that are coming that provide a more ubiquitous, or at least a portable, the ability to run models on different architectures from different systems in a seamless way. These are kind of universal runtimes. And I include in those what Flex AI is trying to do, which is to hide the differences between what NVIDIA does and AMD does and maybe other different other options, and make users have the ability to tap into different compute pools and different options depending on what the workloads are trying to do. So when you run a model, will help you pick one of the options on the market in a seamless way, so that you don't get stuck or you don't get constrained too much about the availability of the Ferrari of AI accelerators or AI GPUs, which are the NVIDIA ones. Maybe there are other options that will suit the use case, and you don't have to wait in line and wait for those the best of breed GPUs. You can actually live with something that is slightly different, that works just as well, or maybe works well enough for the use case, right? These are things that are coming to the market. We also see novel hardwares that like Grok, which are very much focused on inference at scale, where basically it's a collection of smaller chips where the big AI model is split into small pieces, and doesn't have to fit in a single chip, but kind of spread across multiple chips that are interconnected with high-speed interconnects. And now when you're trying to use your model, it's completely different dynamic, and you hit a level of performance that is difficult to achieve, or level of efficiency that's difficult to achieve with traditional architecture. So yeah, there are many companies. There's probably 50 companies in the world right now who are trying to bring innovations at both at the hardware level and the software level, to bring efficiency, to bring choice, and to at the end of the day improve or at least bridge the gap between the supply and demand, and just bring different optimal points within the marketplace.
Great. And as you wrap up, it's clear that while the global CPU shortage is a significant challenge, it is something that cannot be solved. From AI specific chips to strategic collaboration, I think there are many ways that businesses can adapt and overcome. I think the key is to stay agile, think more creatively, and plan for the long term in order to, bridge the gap between the demand and supply of these GPUs. And of course, Flex AI plays a very essential role here, definitely. Thank you so much, Dali. It was pleasure talking to you. We had an insightful conversation regarding the current state of GPU shortage and some of the strategies that could help overcome this challenge.
Thank you very much. Thank you for having me.
Thank you, Dali. So, this is for our listeners. Thank you for tuning in the episode of today's Analytics Insight podcast. We hope this discussion has provided you with some valuable insights into how businesses can navigate the GPU challenges and push forward in their AI initiatives. Stay tuned for more in depth discussion on the technologies shaping our future and always keep innovating. You can, of course, listen all our podcasts on Spotify and other leading platforms. Thank you so much.